Good morning, students. In the previous video session, we have discussed about the escape speed derivation and about the orbital speed. And today we are going to have a new topic. And before going through the topic, you know that around our Earth there are some satellites which is moving. From many countries they are sending the satellites. These satellites which is moving around our Earth. So these satellites are moving around this Earth for a particular height. So based on that we have found the orbital speed of the satellite yesterday. And before that topic we have seen the escape speed. So within that speed, the satellite also can be escaped from this gravitational field. But the satellite is not escaping from this nearby the Earth surface. It is just revolving around the Earth. So there will be some orbital speed. In that speed it is rotating due to the centripetal force which is provided by the gravitational force. And now we have to find out the time period for the satellite. Time taken for the satellite to complete one rotation. We know that satellite which is revolving around the Earth. And for one rotation, how much time taken? That is what we are going to find out, this time period of a satellite. So here we are using the word time period, not time taken, because time taken for one complete rotation we are finding. That is what we are saying time period of a satellite. So to find out this time period of the satellite, we can use our general formula, speed formula. We all know that speed is equal to distance traveled by time taken. So speed is equal to distance by time taken. This time taken we are taking as what? That is what? D by T. Capital T we are taking. Capital T means time period. And small t we are using for time taken. So we know that distance. How much distance traveled by this satellite in one full rotation? Yeah, we know that the circumference of a circle is 2 pi r. That circumference of a circle is equal to this one rotation. So distance we can take what? 2 pi r. Here we can take r e plus h. Why we are taking r e plus h? This is the Earth and this much height. Satellite moves in this orbit. So this is the height, this is the radius, RE, radius of the Earth. So the satellite revolves at a height order, RE plus H. That's what we are taking here, 2 pi RE plus H. Now, speed also yesterday we have found one formula. Orbital speed V is equal to root GME by RE plus H. This is what we have found yesterday, orbital speed formula. So V is equal to root GME by RE plus H. Now substitute this distance and speed formula in this equation. So speed is what? Root GME by r e plus h is equal to distance is 2 pi r e plus h divided by time taken, that is the time period t. Now what you have to do means, here this root, we have to change this root, just write like this, root g m e, and this r e plus h we can write like this, 1 by 2. R plus h power 1 by 2, we can write this root. When we are changing the root for this R plus h, we can write what? R plus h 1 by 2. So 2 pi R e plus h divided by t. Now take this R e plus h here. So root GME equal to 2 pi R e plus h into this R e plus h. R e plus h power 1 by 2 divided by t. Now let's see here. R e plus h power 1 is there. Here R e plus h power 1 by 2 is there. So 1 plus 1 by 2, what will come? Yeah, LCM is 2. 2 plus 1 by 2, so 3 by 2. So this power value becomes what? 3 by 2. We can write this equation as root GME equal to 2 pi R e plus h power 3 by 2 divided by t. Now take this t here. So t is equal to 2 pi R e plus h whole power 3 by 2 by root GME. Now we have to change this square root and this power value. So what we have to do means squaring on both sides. Squaring on both sides. So what we will get means t square. 2 square is 4. 2 square is 4 and pi square. Here R e plus h 3 by 2 is there. When we square, it will come into 2. So 2 cancel. What will be remain? Yeah, R e plus h will remain. R e plus h the whole cube will remain. Power value 2 cancel, and this root GME, when we square, the root will change. So GME it becomes. This is a time period for the satellite. Now what you have to do means, you see this 4 pi square by GME. 4 pi square by GME, we can take it as a constant. Just to take it as a constant C. So 4 pi square by GME we are taking. T square is equal to C into R e plus h the whole cube. So we are simplifying the equation and just write it. Now you got to write this equation in terms of gravitational force. In terms of what? G, gravitational force. So because this gravitational force is providing what? The centripetal force for this satellite to revolve around this earth. So we need to find out the time period in terms of this G. So again we have to take this equation, you can keep it as what? Here what you can keep? Here, okay, 2 you can keep, 2 equation 2. Now we have to take equation 2 from equation 2. Now what we are going to do is, you see, this is the earth and here the satellite orbit. This radius is very much greater. This height is very much smaller. Radius of the earth is very much greater than the height where this satellite revolving around the earth. So here the height of the satellite from the earth surface is only this much and the radius is what? Very much larger. So what we can do is, we can neglect the height of the satellite from the earth surface. Neglect the height means just neglect this h. Just neglect this h from this equation and write. So t square equal to 4 pi square into r e the whole cube by GME. This is what neglecting the h, as we did before in the variation of g with altitude and g with depth and all. This h we can neglect because radius, when we are comparing the radius of the earth and height of the satellite which is rotating around the earth is very much small. Very much small. So when we are comparing both, we can neglect the height of the satellite. Only we can take what? The radius. So here in this, from this equation I neglected the height and from equation 2 we are writing t square is equal to 4 pi square re cube by GME. Now we know that we need this g is equal to GME by RE square. G value is what? GME by RE square. So that is what I told. Time period we are finding in terms of this gravitational force. So what you have to do means, just you have to make this here RE cube is there. RE cube is there. Take this from this RE cube, split and take the RE square down. So RE cube is there. This RE cube split into 1 into whatever RE square. Now 1 plus 2 is 3. Like this RE cube is splitted and just taking this RE square down. So t square is equal to 4 pi square. Here one RE is there, RE. Then GME by RE square. So this step is very, very important here. We need GME by RE square. GME by RE square we need means here RE cube is there. We have just splitted this into RE into RE square. That square we are taking just down to this GME. So it becomes what? It becomes G. So this one. So this equation becomes t square is equal to 4 pi square RE divided by, instead of this G, instead of this what? G. So G. Instead of this GME by RE square, we are taking what? G. Now take this square. So t is equal to 4 square. So root, no? When you are taking this, it will come like this: 4 pi square RE by G. When you are taking the square root of 4 is Square root of 4 is 2. Square root of pi square is 5. So remaining you can write what down. Square root of r e by. So this is the formula we use to find out the time period of the satellite for one rotation. T is equal to 2 pi into root r e by g. So if you know the value of the radius of the earth, we know no. So g value is 9.8 and the radius of the earth is 6400. If we substitute pi value 3.14, if we substitute and calculate, we will get the time period for the satellite to complete one rotation. So how much time taken for this one rotation, we can find out by using this formula. So listen here. So we are finding the time period for the satellite to complete one rotation. For that we use the equation speed is equal to distance by time taken. This is the general equation, and here we are using time period because satellite cover one full rotation. So the time taken for one complete rotation is called the time period we are using. And the distance covered by the satellite is 2 pi r, and here the r value is r plus h. Then speed is orbital speed root gme by r plus h. Then this 2 value we are substituting in this formula. Then what are? Here in this step we are just changing the square root and writing 1 by 2. And the next step we are taking this r plus h 1 by 2 here. So 1 by 2, here 1. Next step adding the power value. So 1 plus 1 by 2 is 3 by 2. Now in the next step we are taking what are? The t here and root gme down. Then just squaring the both side equation. Squaring this equation on both sides. So t square, 2 square is 4, pi square. Here 3 by 2 into 2 will come. So 2 is cancelled. 2 is cancelled. Now it remains what only q. So this is a time period, and after simplification we can write this 4 pi square by gme by using a constant c, just a constant c, and from this equation again we can find the time period in terms of g. For that we need to find out 4 pi square by gme. You see here re cube. What happened to this h? What happened to the h? Yeah, h is very small when we compare to the radius of the earth, so it is neglected. Now only remains re cube. From this re cube, if we are taking on re square down to this gme, it will become g. So we are doing that, splitting and changing. So remaining 4 pi square re by g we will get. And in this step gme by re square is g here. Now putting the square root of, we are using the square root 4 is 2, and square root of pi square is 5. Then square root of re by g. This is the formula we use to find out the time period for the satellite to complete one rotation. And the next one is energy of an orbiting satellite. Energy of an orbiting satellite. Now, you know this, when this satellite revolves around the earth, it possesses some energy. It is upside, so it possesses potential energy, gravitational potential energy. Also, it possesses kinetic energy because it is what revolving around the earth. So, it possesses some gravitational potential energy. U is equal to minus G M E by R E. So, here R means R plus H. Here M, yes, mass of the satellite. M must mean mass of the satellite. M means mass of the earth. So G, this is what gravitational potential energy formula. And kinetic energy, you know, kinetic energy is equal to half m v square. Here m is mass of the satellite. So when this satellite orbiting revolving around this earth surface possesses some gravitational potential energy minus g ms me by r e plus h. You know r e plus h means earth radius this height. So r e plus h. So and the kinetic energy half mv square. Now we have to find out the total energy used to orbit the satellite. It is one of the important 3-mark question. Very simple derivation. So to find out this total energy, before that we know this v value. Orbital speed is what? Root g m e by r e plus h. This is what g value. Orbital speed gme by re plus h. Now v is equal to root gm e by re plus h. This you take equation 1, this you take equation 2, this 8. Now substitute 3 in 2. Substitute equation 3 in equation 2. Instead of this v, we have to substitute this one. So kinetic energy is equal to half ms m e half ms into v square. V square means this root g m e by r e plus h the whole square. Now when you are taking this square, this root will change. When you are taking this square, what root will change, so we can write down half ms g m e by r e plus h. This equation we can write kinetic energy is equal to 1 by 2 g rearrange and write m must m e by 2 into r e plus h. This is equation 4. So listen here. This we are finding the kinetic energy. We know this v square, half mv square, and v means the orbital speed of the satellite, and we have found yesterday root gme by r plus h, and substituting this root gme by r plus h in this equation 2. So substitute 3 into. Well, we substitute here v square. So while doing this square, this root will change. So 1 by 2 ms gme by r plus h will get. Just rearrange and roll down g ms me by 2 into r plus h. Now we have to find out the total energy E. Total energy E of a satellite. E is equal to kinetic energy plus potential energy. Just adding the kinetic energy and the potential energy. So E is equal to kinetic energy is G M E ms textbook it is given ME, MS. If you are writing MS, ME also, no problem. So we can follow the textbook. So ME, MS by 2 into RE plus H. Here plus, then U value is minus G M E M S by RE plus H. Plus into minus, minus. Now we have to add. Before adding, G M E M S, G M E M S, here RE plus H, here also RE plus H. So G is common, ME is common, MS is common, RE plus H is common. So take this term outside. So E is equal to G M E M S by RE plus H. We have taken outside. So inside bracket G taken, ME taken, MS taken, RE plus H taken, only remains 1 by 2. 1 by 2 minus here G taken, ME taken, MS taken, RE plus H taken, remaining 1. So 1 by 2 minus 1. G M E M S by RE plus H. 1 minus 2 by 2. Just taking the LCM and solving 1 minus 2 by 2. So 1 minus 2 is what? Minus 1. So E equal to G M E M S into RE plus H. Here 1 minus 2 minus 1 by 2. Now next step, just taking this minus 1 by 2 here. So E equal to minus G M E M S by 2 into RE plus H. This is the energy of an orbiting satellite, and here some minus sign. This minus sign indicating the satellite which is not escaping from the Earth's surface, it is bounded. It is what this minus sign shows. And energy of an orbiting satellite, just remember, go through this. You have to, when a satellite revolving around the Earth, it possesses some gravitational potential energy and kinetic energy. So the gravitational potential energy minus G MS MV by RE plus H, and the kinetic energy half MV square. And here we are using MS ME, mass of the satellite, and mass of the Earth. And now here kinetic energy, we have to substitute the V value, orbital speed value. So root GME by RE plus H. We are substituting here, and we are finding the kinetic energy. So we used to get we will get G MS MB by 2 into RE plus H. Now just finding the total energy, adding kinetic energy and the gravitational potential energy. Here while adding, minus is there, so minus will come here, and G ME MS by RE plus H is common, just taken outside. So bracket inside bracket 1 by 2 minus, here 1 will be there. So we are taking the LCM, 1 minus 2 by 2. So minus 1 by 2 will come, just taking outside and out. That is what energy of an orbiting satellite. Now you can check your page number 24, time period of a satellite. That is one important 5-mark question. Mark and practice it. It is on derivation, so practice it. So here in calculation also given. After substituting the value of RE and G, you will get what? Orbital time period T is equal to 85 minutes. So for the satellite to rotate, one complete rotation is 85 minutes. It is what until that you can mark and study time period of the satellite. 5 mark question. And page number 25, energy of an orbiting satellite. Until page number 26, the first paragraph, the negative sign in the total energy implies that the satellite is bound to the earth and it cannot escape from the earth. So this energy of an orbiting satellite is very important 3 mark question. Very important 3 mark question, mark and state. And this is your tomorrow's homework as well. You have to sit and practice. Write in your book. Do it as your practice. Thank you all. Bye bye. See you.